in this review unit, we're going to look at protein synthesis. That was Unit 6. I think it's that coral packet or whatever. I'm starting with question 70 in your review packet. So, what determines which protein is going to be made? The sequence of nitrogen bases. Keep that in mind. Let's go over what a DNA nucleotide looks like. So, going back to this, taking you back to August or September, October. It's the house with the pool and the garage. Okay? The house is going to represent the sugar. This is either deoxyribose or ribose, depending on if it's DNA or RNA. The pool is going to represent the phosphate. A covalent bond is going to hold that phosphate sugar together, which is very strong. It does not want it to break. Over here, the garage is the nitrogen base. I just filled in G, for example, which is going to pair up with C. What holds that together? A very weak hydrogen bond. It is going to be broken, and then they'll glue back together. Okay, that is a weak hydrogen bond. This is a nucleotide. That's the part of DNA. Now, the differences in DNA and RNA. First of all, DNA is double-stranded. It also has a deoxyribose sugar, and we use AT, G, and C. RNA is single-stranded, and we use ribose, and then it has a U, G, and C. That's how you know if you're in DNA or if you're in RNA. They are both made up of nucleotides. Now, replication we talked about in the last video on the cell cycle. Replication is taking DNA and replicating it to DNA. Transcription. Transcription takes place so that the DNA, the code, can get outside of the nucleus. DNA is double-stranded. It's way too big to fit outside the nucleus. So mRNAs come in, is going to be made. That's transcription, that process itself. And then it's going to leave the nucleus and go find the ribosome. So transcription is going from DNA to mRNA. mRNA is very important. I guarantee you on your EOC, you will see an mRNA codon chart. You can only use the codon chart if you have mRNA. You can't use it with anything else. So if you have DNA, we've got to get to mRNA. If you have tRNA, we've got to get to mRNA. Keep that in mind. I bet you'll see something like this instead, DNA to mRNA. Translation. The mRNA is going out of the nucleus. It's going to the ribosome. It is literally inside the ribosome. The ribosome is reading that information, and it's bringing, it's like, hey, tRNA, come on over. The tRNA comes over and attaches to the codon. A codon is 3 mRNA bases hooked together. So the anticodon, which is tRNA, is going to come and attach to it, and it's carrying the amino acid that corresponds with the mRNA, which you will find in your codon chart. All right? That is transcription and translation in a nutshell. The charts, we need to go over how to use the chart. The chart will be used, this little guy right here. You'll see a better one on the EOC. The first base in the codon is on the left-hand side. The second base is at the top, and the third base is on the right-hand side. If you just go in order, left, top, right, you will find the proper codon. Keep in mind, you have to use mRNA. That's protein synthesis.